Welcome to my new video. In this video, we shall see a do-it-yourself build of a ESP32-based SMD rework station. A SMD rework station is very handy in servicing of SMD boards where a conventional soldering station has its own limitations. The SMD station presented here is fully designed and developed in-house from drawing, PCB making, assembly, coding, testing, enclosure with front panel labeling. The function of the SMD rework station is controlled by power board and processor board. In the power board, we have transformer, TRIAC to switch on the 230 volt 500 watts heater, MOC3041 circuit, the 24 volts fan drive, and other safety circuits. In the processor board, we have the ESP32 development kit with interfacing a 2-line LCD display, an encoder for inputting data, PC communication port along with safety circuits. Both the power and processor boards are double-sided PCB, but no PTH is required. Instead, the upper and bottom tracks are stitched with wires and component leads. The full details of the project, including circuit diagram, PCB files, MicroPython firmware, and the required third-party drivers with detailed documentation including engineering calculations are available for download in my GitHub repository. Also, a step-by-step build guide is available at Instructables. Development logs are posted in academic.io. These are etched boards. What we see here is the fully assembled power board and processor board. The processor and other ICs are yet to be inserted. The power and processor boards are stacked one over other to save space. This is the fully assembled unit and it is ready for usage and testing. This is a simple PVC stand made for the handle with a magnet fitted on one side for activating the reed switch of the handle. In the final assembly, we have magnets fitted on both the sides so that orientation of the handle while placing on the stand does not have issue in actuating its reed switch. On power up, the display shows the startup message and stays at user input screen. We have fixed a 8 mm nozzle in the handle. We shall select now by rotating the encoder knob and confirm it by pushing the push button of the encoder. At this stage, the unit is ready for working with default temperature set at 250 degrees C. We shall raise the temperature setting to 300 degrees C. When the handle is lifted from the stand, the heater switches on. The heater temperature rises quickly and as it approaches the set point, the rate of rise is slowed down and attains the set point value, maintains the temperature. We will be having 3 videos on this project. The first one on the gadget general details and assembly, that is this video. The second one will have all functional explanations including using of nozzles, calibration, settings and user limits. The third one will be the behavior of the unit, study on temperature of output air versus heater, the effect of back pressure generated on usage of different nozzles, scope for development, etc. Please subscribe for not to miss these updates. When the temperature settings are increased further, the actual temperature follows and maintains at the new setting. Now let us remove a SMD IC from a board. This is a HCSR04 distance sensor board with the ultrasonic transducers removed. We shall remove one of the IC. We shall remove one more IC. The working is smooth. Stay tuned with us for part 2 and part 3 for more details. Thanks for watching. Please subscribe, share and give a like if the video is useful.